Guys, welcome back to another video. Today we're going to be making a movement system for the game. So yeah, it's going to include um, sliding, running, climbing, crouching, and dashing slash rolling. So yeah. So first off, we need animations. To be honest, I don't know what I need for this. So I'm just going to go in here and find. Uh, okay. Um. See if this has any good animations inside of it. So, okay, that's really dookie. Okay, that's. Oh, run. Okay, roll. And I guess you could just reverse that backwards. Okay. And then that's okay. Yeah, it's gotta find some good animations. And I know there are some animations. So we got idle. Okay. Alright, this is what we needed. We'll keep these two rigs here. So let's get rid of that and this. So the first thing, let's also get rid of all these random scripts. I don't know. Okay. So first thing we're gonna do is create a folder in movement. We're going to call it um we're gonna have one called animations, VFX, sounds, and models, welds. Alright. And then, so the first thing we're going to start doing is create our animation objects. So we're going to have sprint, idle, dash forward, backward, left, and right. And then slide. I think we're missing crouch. Yeah, that one. Isn't even anything in here. Alright, this is starting to piss me off. Okay, shoot. This one we already have. This need a crouch, really. Um, crouch. This will use this. Okay. So we're gonna have crouch, idle, crouch, walk, and we have slide, crouch, crouch, walk. Let's have one for when you're on an edge. So let me move I finally found all the animations. I'll be posting all of these rigs into my Discord server, so if you want access to them, you're gonna have to join my Discord server. Okay. Anyways. So let's quickly, I also added my own animation for a swing. It's really bad, but it does its job. It's gonna be for swinging off tree branches and stuff. So it's gonna be pretty good. Okay, let me just this. Okay, if this guy keeps yapping, there's gonna be issues. Um, do not disturb. Okay. Boom. Just like so. Okay. So this is gonna be pretty nice. We got every single animation we need. So let's call this animation swing. Then we're gonna have an animation called boost, and then we're gonna have an animation called edge, hold. We're gonna have one called vault, and let's quickly export all these animations. So, first we have ledge, hold. Make sure the animation party is action, and make sure it's looped, and just click publish. And make sure to name your animations. Even though it's annoying to do, naming animations is really, really important. So we're gonna go Asset cat. Oh wow, you can do this now. Yeah, it's gonna be an animation. Development item. Hold movement. So this is how I like to name my animations. I like to give it the name of the animation and in which branch it's in. So it's in the movement. And check this. It'll improve your loading speeds by a lot. So it'll just delete any duplicate animations you have. So it's pretty good. So edge holds, put that in there. And it should be nice. Then we got landing. This is for landing on the floor. I'll make an animation for that. Call this one landing. Pretty nice. It's an action. Landing. Movement. Alright, pretty nice. Just like so. So land. Paste that in there. What? Then we got vault. This is nice. Alright. Make sure it's in action. And then let's publish it. Vault. Movement. Alright, so it's gonna be 4 vaults right here. Then we have boost. This is gonna be for climbing up a wall, kind of like in Deep Oaken. You've seen that before. Yeah. Let's start Deep Oaken there. So delete local instances, true. Click save. And you got something nice right here. So if we have right there. And then ledge climb. Alright. This is gonna be for when you climb a ledge. So oh, no, sorry, we're gonna publish it. Let's just ledge climb movement. Let me. Okay, just like so. Let's just do edge climb. Change it to this. Then we finally got we got an idle animation. We're gonna have different idols for different weapons in the future, but combat will be the next video. So idle movement, so boom, and bow. We're filling these animations in one by one. Then we have slide. Publish that to Roblox. Slide. Put that in there. Then we have running. Oh no, I don't really like that running animation. It's kind of big. Let's run 2. I like this running animation way more. Let's look at the other ones. Yeah, no, we'll stick to this. Give it action. Let's just see what it looks like with a playback speed of 2. Oh, that's ugly. No, we're good. And then let's just hit. Make sure it's in action. We're gonna call this sprint. Bracket movement. Just like so. Alright. Um, oh yeah, we got front roll. Holy crap. Oh, that's 6.5. Front roll, just like so. Picture in action. We're gonna call this roll forward movement and continue doing all of that. So if we go roll, all right, and then just for moving back. So we're gonna do roll backward movement. Boom. Bam. Bada bow. Just like so. Then we got right. That should just like so. Right. Movement. And we don't really have that much animations left. So let's rename these to roll instead of dash, just because they're rolls, not dashes. Dashes are from when you're in the air. And we got left roll. So let's publish to Roblox. Roll left. Alright, just like so. And then if you want, we could add a walk animation, but it's not really needed. Good. Okay, then we got our crouches. So this is our idle. Obviously gonna be action, crouch, idle, movement. Alright, just like so. Crouch, idle. Crouch, walk. Just like so. Alright. Let's paste that in there. And then we finally got our swing animation. Let's publish this as an action. Swing movements. So that's quite a bit of animations, but just like so. Where is that swing? If we go through this, every single animation. So every single animation should have an animation. And they do. Okay. So first off, let's go ahead and implement our idle animation. So let's create a service here. We're gonna call this one movement service. Then we're gonna reference replicated storage. Alright, so game get service, replicated storage. Make sure you spell it right. Local server storage equals game get service server storage. And it's gonna do local replicate or local assets equals replicated storage. Wait for child assets. Local shared equals replicated storage. Wait for child shared. And then local we don't need clients. That's all we need actually. And then what we're gonna do is we're gonna say local service, reference it as a table and return service. Then let's create our own custom function called service, character added. We're gonna parse in our character, and then we're gonna do function service register server init. And we're gonna say, let's get player service in here. We're gonna say players dot player added connect function connect it. We're gonna get a player. Say player dot character added connect function character added with our character obviously. And then this is a safety check, but this is just in case a player loaded in before this script loaded in. Just safety. And then service, character added, character. And we're going to reference the animate script. So we're going to say character.animate. We're going to say animate.walk. The animation ID equals assets dot movement dot animations dot. Oh no, we're doing the idle animation. So let's do the idle the animation one dot idle dot animation ID, and repeat this but with your animation too. Alright, and then if you hit play now, should be working. So oh, we should make sure to change your avatar type. So go in game settings, avatar. Well, I am the game owner. This guy's stupid, bro. Set it to R6 and set the animation to standard. And hit play. This game on crack. I don't know, bro. Let's see. Okay, there we go. You can see we added in the new idle animation, just like so. So, yeah, that works. So now let's go ahead and start working on our sprint. Okay, so let's create a module in shared, and we're going to call this module script movement handler or movement util. Util stands for utility. And then let's just start referencing our services. So make sure to comment out your code, just in case in the future when you come to read it, it's really easy to read. So I'm gonna get replicated storage equals game get service replicated storage. Then we're gonna get user input service, game get service, user input service. Then we're gonna get tween service equals game get service tween service. Then let's go ahead and get debris service equals game get service. Just to make this organized, I like to organize my variables from longest to shortest. So, and then let's go local run service equals game get service run service. And we won't actually be using debris. Debris is a little inefficient, so let's make our own module for that. we're going to create a module script called debris, and we're actually just going to return, oh, my internet, guys. Oh, my internet's doing amazing. So let's create, so we're actually just going to return a function, and we're going to need two arguments. We're going to need the duration, which we're going to make reference as a number, and we're going to need an item, which is going to be an instance. And we're going to just do task.delay duration item.destroy item. This works a lot better. The reason why it does is because debris runs at 30 hertz. Game.debris runs at 30 hertz. This module runs at 60 hertz plus. So yeah, pretty much debris runs a little too slow for our liking, and it's really inaccurate. So this is going to be a lot more accurate. So if we were to reference this again, we're going to say local debris service, and actually we can't add that just yet, because now we're going to reference our directories. So alright, so we're going to go local shared was replicated storage wait for child shared. Then we're going to do local assets equals replicated storage wait for child assets. Then we're going to do local client equals replicated storage. Then we're going to do local movement assets equals assets wait for child movement. We're going to do local movement anims equals movement assets wait for child animations. Local movement VFX equals movement assets with child VFX. Local movement sound equals movement assets with child sounds. Local movement welds equals movement assets with child welds. Local movement models equals movement assets with child models. And then so directories right here. And then after that, we're going to reference all of our utilities. So we're going to have our remote library equals require shared the remote library. Then we're going to have our debris util shared debris. Then we're going to have our bucket util this is debris, this is made. Oh yeah, and let's reference made as well. So local made util equals require shared made. And then you can see whenever we run debris util, it references it as a function with duration and the item you want to destroy. Okay. Now let's create a remote for our movement. So if we were to go in here, remote library events, let's just clone this example event and call it movement events. And then inside of our remote library, let's do, oh my god. Okay, so let's go ahead and do, let's unreference this actually and just call it movement events. Let's do require script dot or events dot movement events. Yeah. So now we're gonna have our remotes So local movement event is equal to remote library dot events dot movement event client. Pretty sweet. And then now let's reference our configs. So inside of our configs folder here, so first off, let's go back to our directories and we're gonna say local configs equals assets dot configs, or boom. And then inside of our configs, let's create a module script and we're gonna call this movement config. And let's return a table, and this part is going to be for keys. This one is going to be for values. All right, so yeah, so first off, we're going to say sprint key. It's going to be enum.keycode.w. We're going to say sprint, all right, and we're going to say dash key. It's going to be enum.keycode.q or q, just like so. Then we're going to say shift or mouse lock key is going to be enum.keycode.left control or left control. Actually, let's make this tab. Then we're going to say swing key is going to be enum.keycode.space or space. Also, we only do this just in case you can't reference the enums. So, and then we're going to have one for, oh yeah, crouch key be enum.keycode.control or left control. Then we're finally going to have slide key. It'll be enum.keycode.left control or left control. Then we're going to have our climb key, enum.keycode.climb or space. And yeah, don't think we're missing anything else here. Let's just clean up our Explorer. We took our animations, I think. Yeah. And then let's do our vault key, I guess. Key, which is also enum.keycode.space or space. Now let's make our values. So we're going to say sprint type is equal to hold sprint tap. You need to press it twice. Then we're going to have our dash distance. It's going to make you go 10 studs. So move you 10 studs. Times you need to move click W to sprint, and then sprint type you can either have toggle or hold. Then we need swing distance. We're gonna make it send you 25 studs. Then we're gonna have our climb distance, which is going to move you 10 studs. Yeah. And I think that's kind of it. Yeah. So we have our movement config. Let's go back to our movement utility script. And we're going to say local movement config equals require configs dot movement config. Okay. Okay, let's put this down here in the config section. Just like so. Code nicely commented out. And then now we're gonna create a function. Right. Where let's say local service return service. I'm gonna say function service register client character. We're gonna ask for a character, which is gonna be a model. And then let's create our meta table. So we're gonna say local self equals to set meta table service to a new table, and let's return itself. All right, and then from there we're gonna do functions. Let's make some placeholder functions. Let's have one called sprint. Let's have one called vault. Have one called climb. Have one called ledge. Let's have one called slide. Let's have one called swing. And let's have one called crouch. Phew. So let's just return pass on all these functions. Just to know that these don't work yet, but and then let's just start referencing our stuff. So we're gonna say self.character is gonna be equal to our character. Our humanoid is gonna be our character humanoid. Be a humanoid. Then we're gonna have our animator self.humanoid. Wait for child animator. Then we're gonna have self.root part, self.character.primary part. And then we're gonna have our then we're gonna say self.sprinting. Yeah, we're gonna say self.sprinting equals false. Self.climbing equals false. Self.edge or self.ledge hold equals false. We're gonna say sliding false. Say swinging equals false. And we're gonna say self.dashing equals false. Yeah, and then self.crouch equals false. Okay. Then let's quickly reference all of our animation tracks. So this is a good place to put all your animation tracks. So let's quickly comment out what we're doing. Good thing about loading all our animation tracks here is that they won't lag when you first use them. So it's like an animation loader. Temporary values. And then our character properties. Instead of temporary, let's call these dynamic values because they're always changing. So, and then we're gonna call these static values. Okay, and we're gonna say self.sprint track equals self.animator. Oh yeah, let's just say that he's a animator. The base part. Self.animator, load animation, movement anims dot sprints, self.climb. Look, yeah, self.animator, load animation, start for think it's called boost. Yeah, boost. Then we're gonna have our ledge hold track anims dot ledge hold self dot ledge push track, just like so. Then we're gonna have our slide track. Then we're gonna have our swing track. Then we're going to have our dash forward track. And then our dash backward track. That's all our dashing stuff. Oh yeah, let's get our crouching stuff. So crouch idle, and then self dot crouch. And we're gonna have so this is just for when we play our landing animation. Alright. And then we're gonna have our landing track. Phew, that was, holy crap, that's long. What we're going to do after here is we're gonna handle our input, or our maids, I guess. So what we're gonna do is we're gonna say self.event perm event made new. Then we're gonna have our what was it? Our VFX made new. Then we're gonna have our sound made, and finally we're gonna have, we don't need a sound made, VFX made can just handle that. Yeah, okay, think that's pretty good. And we're gonna have some events. Okay, we're gonna say self.perm event made give task user input service to input begin. Boom. Say let's do this again, but with input ended. Uh, okay. So now let's quickly go ahead and yeah. So we're gonna say if input. So we're gonna say if GPE then return it. All right, that's an obvious one. Then we're gonna say if input.keycode equals movement config dot sprint key. Then we're gonna say if movement config dot sprint type is equal to what should we call it? Hold, then else. We're just gonna say self.sprinting equals not self.sprinting. And we're just gonna do self colon sprint. Okay, pretty easy. Then we're gonna say here, we're gonna have to reference a new variable called self.sprint tab interval. It's gonna be os.clock. Okay. And what we're doing with os.clock is calculating intervals. And actually, let's set this to 0. Because, why not? Then we're going to say self.sprint tap cooldown, or minimum 0.3 seconds. So, okay, so this is how fast you have to click it. If it takes you more than 0.3 seconds to click W again, it'll just reset your tap. Alright. And then let's just do another self.perm event made. And let's give it input begin, or run service actually. Render steps. And we're gonna say if os.clock minus self.sprint tap interval is greater than self.sprint tap minimum. Then self.sprint tap no sprint tap. Let's just do this. Alright, and we're gonna say if self.sprint tap is less than 1, then self.sprint tap plus equal 1, we're adding 1 to it, else self.sprinting equals true, self-colon sprint, and then we're going to self.sprint tap is back with a 0. Really easy stuff here, pretty nice. So I know this is going to be for sprinting. We're going to increment tap value by 1 if tap value is equal to 0. Then we're going to increment it. Okay, so we're just going to increment it by 1. Next tap will be a sprint tap. Okay. And then, we're always gonna set the sprint tap interval. Always set it to os.clock. We're gonna reset the interval here. Then we're gonna set sprint to true. And we're gonna sprint, call sprint function, and reset sprint tap value. And let me just quickly fix up my comments so they look a little cleaner. Right, give these nice arrows. This is for toggle. Just set sprinting value to the opposite. And then we're just gonna call the sprint function. And we're just gonna say this is for tapping W when player presses sprint key. Pretty easy stuff here. And then what it's gonna say inside of here, what it's gonna print. Uh, so we're actually gonna make a conditional statement, a Boolean statement, as people would call it. Watch. You're gonna make brackets, and we're gonna say self.sprinting equals to true. We don't even do that. You can say if self.sprinting, then we're gonna make it say sprinting or not self.sprinting. So if it's not sprinting, we're gonna make it say walking. And then so we have this, but it won't actually run because we need to make a client script. We're gonna call this movement controller. Let's just reference all of this stuff right here. I'm gonna say local controller, return controller, and we're gonna say function controller, register client character. Gonna parse into character. I'm gonna say local movement handler require shared movement util dot also set this. Oh no, this should be dot new. Sorry. Yeah. There we go. Dot new. And I'm parsing the character, and yeah. So now it's loaded into the game and see what happens. So if we double tap W, let's just make sure it's actually running. Give me a second. Register client character. We're just gonna print ran. We're gonna print ran, and then obviously in here we're gonna print tap. Okay, so the function didn't actually run, did it? Let's see issue for this. Oh, it might be from the remote library. Guard red.events. Let's just add a second validate function. Let's return this just in case an error pops up. And we're actually going to change this to event options. So our name is going to be script.name, and reliable is going to be false. That should work. All right. Let's just make sure any. Okay, give me a second. I'll fix this really quick. Okay, guys. So I figured out what the issue was. We just got to make a server script that references red with the remote library. So easy enough. We're just going to say local remote library equals require shared dot remote library, and the issue should be fixed. So this is hit play now. Boom. Yeah, sprinting. Just like so. Let's remove all of our prints just because it looks a little ugly, you know what I mean? Just like so. Here, this tap sign. Oh yeah, and then we're gonna say if input.keycode equals enum.keycode equals, or sorry, movement config dot sprint key. If movement config dot sprint type equal to hold, we're gonna say self dot sprinting, or if self dot sprinting, then self dot sprinting equals false, and we're just gonna do self colon sprint. Boom. And let's just make sure if self dot sprint. But we actually won't need this, just for safety. Yeah. If we hit play now. That's a little funny. It does it twice. We don't want that. No, 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 no. So we're just gonna set this to less than or equal to 1. No, okay, no. So if self.sprint tap is so. Oh, it indents it by 1 anyways. There we go. Just like so. Alright, now it works. So if player tapped twice. Just like so, and now let's add some safety statements, obviously. So if not self dot sliding and not self dot ledge holding and not self dot swinging and not self dot dashing, or no, let's just say if, and we'll just do a bunch of ors, or then return it. Simple. Just like so. We don't need to put that here. Let's just comment this out. When player releases sprint key, we're gonna say if sprint type is equal to hold, if sprinting, set sprinting to false, call sprint function / method. Really simple. Alright, let's just comment this out. It's just like so. And then this is just making sure if it was more than, right down here, reset sprints if time since last press is more than 0.3, then yeah, so we're gonna reset our sprint. We're gonna 1 hour here. Okay, we're gonna reset our sprints and yeah. Yeah, I guess that's that. Let me just, I just like to save this to my modules folder. So really nice, yeah. No, let's just, okay, so render step function which runs every frame, right? So now if we look at this, so we have a event here that runs every single frame. Then we have an event here that runs every single time you let go of a key. If the key is equal to the sprint key, if the sprint type, input type is holding, if we're sprinting, we're going to set sprinting to false, and we're going to call this sprint function. All right. Then we have an event here which runs every single time you start interacting with an input type. If we're interacting with any of Roblox's core UI, then it's going to return, it's just not going to do anything. If we press the sprint key, if we're not sliding or holding onto an edge or swinging or dashing, and then we're going to check if our sprint type is equal to holds. We're going to make sure we're not sprinting. We're going to reset our sprint tap interval. We're going to increment our sprint tap value by 1. If sprint tap is greater than 1, which means we've pressed it twice, then we're going to set sprinting to true. We're going to call the sprint function or method, and then we're going to set sprint tap to 0. If it's toggle, we're just going to set sprinting to the opposite of sprinting and call the sprint method. Really, really easy, right? Really easy. So now let's actually, let's just make this look a little nicer. Movement, sprinting. We're gonna say if self.sprinting else, and we're gonna say if self.humanoid.move direction.magnitude is greater than 1. We're gonna say self.sprint track play with 0.1 fade time, maybe like 10 weight and 1 speed. All right, and then obviously we're gonna set the walk speed to 26 and the jump power to, actually we don't even need to touch the jump power. Then we're gonna say we're gonna say if self.humanoid.move direction.magnitude is greater than 0. We'll do the same thing here. It's greater than 0, then self.sprint track stop. Just like so. And we're gonna say self.humanoid.walk speed is equal to 16. Pretty easy. So this is if player sprinting, if player not sprinting, we're gonna set walk speed to default walk speed, set walk speed to increase by 10 to 15%. I'd say like 50%, honestly. Or yeah, like 50%. Then if player walking, we're gonna play the sprint animation. If player moving stop sprint animation. Also, humanoid dot move direction dot magnitude. This just means if it's greater than 0, it means they're moving around. Whether that's like, yeah, it just means they're moving. If it's equal to 0, it means they're just idle. They're just standing still. Okay. And so if sprinting, I'm just gonna do a little. If sprinting, the output movement sprinting. If not sprinting, then output movement sprinting. It should look something like this now. So yeah. And then now we're gonna have a new. So let's create another dynamic value up here called self.previous move direction to math.round self.humanoid.move direction.magnitude. Okay. And then we're gonna create another event. So self.perm events give task run service.render steps, or no, self.humanoid.move direction, or get property change signal, my bad. Connect it to a function. We're gonna say local move direction equals to math.round self.humanoid.move direction.magnitude if move direction is not self.previous move direction, else we're going to say if move direction is equal to 0, else if self.sprinting, then self.sprint track stop 0.1. If self.sprinting, then self.sprint track stop 0.1. So this is pretty self-explanatory, really. So every single time the move direction changes, this runs. Then we're gonna round up our the move direction. Then, if players switched from moving to idle, or vice versa, we're gonna say if they are sprinting and if they are idle, stop sprint animation. Pretty simple. If players switch to moving, then if they are sprinting, play animation. And let's just quickly hit the play here with a 10 weight and 1 speed. And let's just make this actually look like what we're supposed to do, because I don't like how there's no arrows. Like I said, keep your comments consistent. If you're going to do a commenting style, continue that commenting style. But yeah. So if we try this out now, it should run. Yep. What's this goofy animation? Oh yeah, we forgot to set our previous running values. So let's go ahead and do that. We're gonna say up here, self.previous move direction is equal to move direction. Alright, just like so. So now if we hit play, and we were to sprint regardless of if we move around. We still sprint and we stop, just like so. Stop. Sprint animation's a little wonky, but we can always change that. But yeah, it does do its job, so. Now let's move on to dashing. Alright, so let's go ahead and do. You can see we got this nicely organized. So now we're gonna go in and is there a way I could filter a plugin? Studio, yeah. Oh yeah. Whatever. We're gonna say if input.keycode is equal to enum.movement or movement config dot dash key, we are now going to get the dash direction. All right. Now, just quickly make sure to keep up. All right. So, if the player presses dash key, then we're going to get the so we're gonna get the dot product of the character to the move direction. So we're gonna say self.humanoid.move direction dot self.rootpart.cframe.look vector. Get direction player is moving. So we're gonna say if move.product is equal to 1, else if move.product is equal to -1, else if move.product is equal to 0. Here we're gonna print sideways, or we're gonna print forward. Then here we're gonna print backward. And here we're gonna print sideways. So let's go ahead and hit play and see what we get. So why is it not running? Let's check our config real quick. Yeah, dash key is Q or Q. Let's at least print the move.product. Oh yeah, I think I might have forgot to do the whatever. Let's hit 5 and see what we get. Oh, we gotta round it up. Let's go ahead and do that. So let's hit math.seal on this. This will just round it. You know, nothing too crazy. We hit play now. Moving sideways, moving forward. Backward does not seem to be working. Let's hit it with a round then, maybe. Yeah, there we go. So you can see when we move forward, it says 1 forward, backward, it says -1 backwards. Now let's figure out the sideways direction. So what we're going to do now is we're going to say move.product is equal to workspace.camera.cframe.lookvector dot self.rootPar.cFrame.lookVector. If move.product is greater than 0, else if move.product is less than 0, we're going to print left and right. See what we got. Yeah, it's clearly not doing its job. Let's fix that up. I'll be right back. Okay, so I figured it out. You're gonna take this and we're gonna go math.round self.humanoid.moveDirection.x. That's what we're gonna do. And then else if move.product is equal to 0, we're just gonna make it right. So if they're not moving, we're just gonna make it right. Alright. So that they automatically move right. Pretty simple, but you can see if we just stand still, it's gonna say right. If you move back, backwards, forward, forward. If we move to the right, it says right. If we move to the left, it says left. That's gonna say right. Okay, that is really stupid. Give me 1 second, guys. That is not the way to do it. Again. Okay, so we just gotta convert it to object space. Let's go over here. Self dot rootPar.cFrame.lookVector or cFrame to objects, or was it? Yeah, to object space. Okay, give me 1 second. Okay, I figured it out. It's vector to object space, and then you just do self.humanoid.moveDirection. Yeah, and then let's try this out. Oh yeah, we gotta get the magnitude of it. Alright, let's try this out now. Right. Okay, that's not happening. We have to get the X. I think we gotta get the X. Alright, let's get the X in. Okay. Right, left, right. Alright, it's working. We don't need caps lock. Okay, so let's hit stop. Go to our movement util. We don't need to print. Actually, let's just keep this here. When we dash, we don't have a dash function. Okay. Function service dash direction, which is going to be a string. And all we're going to do is we're going to send him this string. So it's either going to be left, right, forward, or I think you can do this. Yeah. So it's going to be, alright. So these are the 4 possible answers. So now let's just replace these with the dash key. We're going to say self dash forward, self dash backward, self dash right, self dash left, self dash right, and get rid of this. Okay. And now let's add a cooldown to this. We'll do something like dash cooldown maybe like 1 second. So let's go back to our movement utility. Create one here. This is gonna be called self.dash interval. Set it to 0. And then we're just gonna say if os.clock minus self.dash interval is greater than movement config dot dash cooldown, then, or less than, I guess, then return it. So if it hasn't been 1 second since the last dash. Okay, so let me just quickly go over this. Okay, so what happens is we're gonna check if they click Q or the dash key. Then we're gonna check for the cooldown. We're gonna calculate the interval. If the interval is less than 1, that means there has been less than 1 second that have passed. Sorry for that. So then we're just gonna return, pause, stop, whatever we're doing, and yeah. And then we're gonna get the move direction. All right, the dot product by calculating the two vectors. If the dot product is equal to 1, that means we're moving forward. If it's equal to -1, that means we're moving backwards. If it's equal to 0, that means we're moving sideways. Then we have to calculate if we're moving left or right. So now we're gonna get the humanoid root part C-frame and compare it to the object space. Objects and local space, I'll teach you about later, but pretty much we're just going to calculate if we're going right or left. So if it's greater than 0, we're going right. If it's less than 0, we're going left. And if it's equal to 0, we're going to go right. Equal to 0 means you're not moving. You're not moving. Default is right. You're moving left. And you're moving right. And this right here is going to be relative to object space. So if it was relative to the world space, I could be moving this way, and to me it looks like I'm moving right, but to the world it could be that I'm moving forward. But if it was relative to object space, I could be moving this way and I'm moving right regardless of what the world thinks. If it was to world space, I could be going forward right now, right? This is how what world and object means. It's like it's like the frame of reference. All right. But yeah. So let's go ahead and go to our dash here. And we're gonna say, oh yeah, let's just quickly go back up here, and we're just gonna set self.dash interval to os.clock. Nothing crazy. So reset cooldown. All right, and then down here we're gonna print movement dashing just gonna dash well, this is gonna depend. We're gonna so this is gonna have the direction, and here we're gonna say self.humanoid.floor material equal to air and roll equal to that and dashed. So if they're in the air, it's gonna be dashing or not. Self.humanoid. So if this is actually on a material, if they're not in the air, then we're gonna say rolled and then forward, backward, whatever. Right, pretty easy. And then what we're gonna do here is we're gonna create a body velocity. And then we're gonna say body velocity dot p So aggressiveness, we're gonna say like 1250. And body velocity dot velocity is going to be, so now we're going to make one massive Boolean statement. All right, we're going to say direction equals to left and self.rootpart.cframe.right vector times movement config dot dash distance negative. So this is going to be for going left and or direction is equal to right and self.rootpart.cframe.right vector is going to be times movement config dash distance and direction is equal to forward. So this is if we're going forward, and it wouldn't be and, it'd be or equals to forward. Then we're gonna be going self.rootpart.cframe.look vector times movement config dot dash distance or direction is equal to backward. Just to space it out so it looks readable. And self.rootpart.cframe.look vector times negative movement config dot dash distance. Beautiful. One long juicy line of code. Then we're going to say body velocity dot max force. Don't set it to math.huge, really bad practice. Instead, we're going to set it to vector 3.1 and then just times it by 50 times 100 because I don't feel like writing out that many zeros. So there we go. Okay. And finally, body velocity dot parent equals to self dot root part. And let's give it a name of dot name equal to dash. Let's just take. I'm really specific about my names, so just in case you want to ever debug it, let's keep it like this. And we can say debris util. Give it like a duration of 0.3 and body velocity. And then we're gonna say self.dashing to true. True. Then we're going to wait 0.3 seconds and self.dashing. Go to false. And then we're going to play the animation, which is going to be self dash dot direction track play 0.1 10 1 and so this is going to play the respective animation track. All right, so you can see it's already looking really nice. And now let's just quickly add some safety checks. So we're gonna say if self.sliding or self.dashing or self.swinging or self. No, we'll let them crouch. Then return end. Pretty easy. If you're doing any of these actions, it'll just return. It won't do anything. All right, so let's quickly try this out. So wow, this is doing its job. Okay. gonna try something. 1, 2, 3, 4, 5, 6, 7, 8. Just let me try this real quick. Let's get rid of this P here and see if it does anything. Because the P is going to be a limiting factor. So. Let's see if it even gets added to our character. Oh, it's getting added to our head. So let's go back to our movement service, and we're just gonna say character.primary part equals character wait for child humanoid required. That'll fix it. Now if we hit play, it should actually move you. So now if we were to hit, it still doesn't want to do its job. Okay, now what's the issue? So body velocity. His job is to move you. Maybe the dash distance is too low. Let's make it like 25 times the power of gravity. It doesn't want to work. Okay, I'll figure this out. Okay, so I fixed it. Literally all you gotta do is just increase, all I did was increase the max force to 100,000. Pretty easy. Yeah. You can also, yeah, it's really small amount, so I might make it like 45. And if we hit play now, and we go, but if you're standing, it still brings you a great distance. So, and you can see if it's gonna, alright, yeah, just like so. So, pretty nice. You know, in my opinion, pretty nice. Yeah, so that's dashing. I'll quickly go over it. So first off, we're gonna check that they hit the dash key. And then we're gonna check that they did the dash cooldown. We're gonna check the cooldown, so we're just gonna get the interval here, make sure it's more than 1 second or whatever we put up there. And then we're gonna make sure we're not sliding or dashing or swinging. Then we're gonna reset the cooldown, and we're gonna get the dot product or the move direction. If the dot product is 1, we're moving forward. If the dot product is -1, we're moving backwards. If the dot product is 0, we're moving sideways. Then we're going to get our move direction relative to our object, right, to our object space. If it's greater than 0, we're moving right. If it's less than 0, we're moving left. If it's equal to 0, we're moving right. Pretty simple. And we're going to go to our dash function here. So this is just going to print dashed if our floor material is air, and rolled if our floor material is not equal to air. And I'm gonna just set this to the air, no, to the material air. So, and then we're gonna set dashing to true. We're gonna create a body velocity. Then we're gonna reference the velocity based off the right vector or negative right vector, whatever, so like if it's left, we're gonna do negative right vector times our dash distance if we're moving right. it's going to be our right vector times our dash distance. If we're moving forward, it's going to be our look vector times our dash distance, and if it's backwards, we're going to do our look vector times our negative dash distance. Really easy to do. And our max force is going to be vector 3.1 times 100 times 100, or 100 squared, which I guess I could just do this. This is going to give us 100,000. And then we have our body velocity. So we're just naming our body velocity. This doesn't matter at all. And yeah, it's kind of, and we're just parenting it to this root part. And then we're playing our track based off of the name of based off of our direction. And then we're just going to get rid of our body velocity after 0.3 seconds. And then after 0.3 seconds, we're going to set dashing to false. Really easy, in my opinion. Yeah. And let me just quickly do this, just so it actually does its job. And voila, that is dashing for you guys. So in the next part, I will be adding sliding and climbing, and in the final part, we will be doing swinging and crouching. And then in part 4, we will be doing VFX and sounds. So I hope you guys enjoy this. Have a great day, and see you next video.